Good morning, evening, afternoon, whenever you happen to be watching this class. Today we're going to do chapter 1.3, which is linear functions. Get my cursor ready. So, start out with the definition of linear function. A linear function is a function that can be written in the form f of x equals ax plus b, where a and b are constants. So, is y equals 5 a linear function? Well, can we write it in this function form of function fx equals ax plus b? Let's try. Well, f of x is the same thing as y. So f of x, if we let that be our y here, so y is the same thing as f of x. What would our a be in this case? Now we need to have an x in here, that's our variable, but in this case, in order to get it to be y equals 5, our a would have to be a 0, because 0 times x is 0, it would kind of disappear, right? Then our b would have to be a 5. So can we put this in this form? We sure can. So is it a linear function? Yes, it is. How about, is xy equal to a linear function? Well, we need to get that x away from that y to start with, right? So what we'll have to do is we'll have to divide both sides by x. So now our function looks like y equals 2 over x. And we want to know, is it linear? Well, in order for it to be linear, it has to be a number, a, times x plus b. Now this x isn't in the denominator, but this x right here is. So there's no way for me to get this x from the denominator back to the numerator. So no, this one unfortunately is not a linear function. Now how about, is 0 equals 2t minus s plus 1 a linear function? Let's have a look at this. Now I'm not really sure which one is going to be the y in this case and which one's going to be the x, but I don't really think it matters. If I want to, I can add s to both sides. So I'm going to add s here to both sides, and I get one that looks like s equals 2t plus 1. Now, in this case, x and t will be the same thing. 2 will be our a, 1 will be our b, and it looks like we're in this form. So I'm going to say yes. Now you're going to ask me, you're going to say, Mr. Shipes, what if I had solved for t? What would happen in that case? Well, if you were to solve for t, you would have wound up with negative 2t equals negative s plus 1. You would have had to get rid of that negative 2. So we would have divided by it. We would have got t equals, and I'm going to put this negative 2 with each of these terms. So negative s over negative 2 plus 1 over negative 2. And I can simplify that as well. And I could say, okay, that's the same thing as s over 2 plus or minus. Let's just go straight minus to keep it simple, because that minus is going to take over there. Minus 1/2. You're like, okay, Mr. Shipes. Yeah, what is our a in that case, though? Well, what you could do here is you could say, okay, that's the same thing as s, and I'll do it even closer so it matches the format here. That's the same thing as 1/2 times s minus 1/2. Right? And that's what our t equals. So I'm looking at it from this perspective. My a is just a half. My b is just negative 1/2. And still in this situation, yes, we have a linear function. So we're fine if you work it out either way there. Works both ways. Now let's look down here at this next set of examples where it talks about intercepts. Now, you've got two types of intercepts. The x-intercept, which is the point where the graph crosses or touches the x-axis. And in order to find the x-intercept, Lord, talking funky tonight, aren't I? In order to find the x-intercept, we're algebraically going to set y equal to 0, and we're going to solve. Now for the y-intercept, it is the point where the graph crosses or touches the y-axis. To find the y-intercept, algebraically, we're going to set the x equal to 0, and we're going to solve. Okay? So that's what we're going to do here. So the graph of the linear function can have at most one x-intercept and has, get it, has one y-intercept. So it can have at most one x-intercept, but it's definitely going to have one y-intercept if it's a linear function. Okay, very important. All right, let's scroll down and look at slope and its definition. So we've got our definitions of x-intercept, our definitions of y-intercept, our definition of slope here. Slope is rise over run. So hopefully you've dealt with slope before. Sometimes slope is called vertical change over horizontal change. It means the same thing. The slope can be found by using any 2 points on the line. If a non-vertical line passes through points P1, which is x1, y1, and P2, which is x2, y2, its slope is denoted by m, which is found by m equals y2 minus y1 over x2 minus x1. Now note if we do have a vertical line here, its slope is undefined. Okay, in this definition we're strictly talking about non-vertical lines. But if we happen to have a vertical line, we're going to call that slope undefined. Okay. Reason being is we're going to wind up with a 0 in the denominator for a vertical line, and we know that if we have a 0 in the denominator, it is undefined. Now let's look at some examples here. First example says, find the slope of the line between the points -3, 2 and 5, -4. So let's do that really quick. Now what I like to do is go ahead and list my points here. I'm going to call this one x1, this one y1, this one x2, this one y2. And I get it every semester. They say, Mr. Shipes, does it matter which one is x1, y1 and which one's x2, y2? If I were to switch that and made this one x2, y2 and this one x1, y1, would it make a difference? It does not. The only thing is x1 and y1 have to go together and x2 and y2 have to go together. So you can't call this one x1 and this one y2. You have to have the ones together and the twos together in the same coordinate point. So let's do it. We're going to do y2, which is -4, minus y1, which is 2, over x2, which is 5, minus x1, which is -3. 4 minus 2 is -6. 5 minus a -3 is a +8. We always want to reduce our fractions as far as we can. So we get -3/4. So our slope between these 2 points is -3/4. Easy enough, right? Now if we want to look at 2 here, it says determine whether the slope is positive, negative, 0, or undefined. Okay, and it kind of helps you out here, kind of gives you the answers here with these little m values. But we'll notice what a positive slope is a slope that goes up. So it starts down and then it rises, right? A negative slope, or when a slope is less than 0, is when it goes down. So you notice that we have a downward slope here, or a negative slope here. So this is a positive slope. This is a negative slope. This slope here is a slope of 0. So the horizontal line always has a slope of 0. So we have a horizontal line here, and so we see that our slope is 0. So what I'm going to do here is remind you that this is a horizontal line, and that its slope is 0. Now here we have a vertical line, and its slope is undefined. So there are your 4 cases. So we got positive slopes, negative slopes, a slope of 0, and an undefined slope. Easy enough to remember there. So question 3 is going to ask us to graph y equals 3x plus 2, and it wants to know what is the slope, what is the y-intercept, and what is the x-intercept. So let's kind of go through here first. And let's see if we can pick these things out and then graph it. It might make it a little easier for us to graph it if we know A through C. So the slope is always the number in front of your x here on a linear function. So our slope here is 3. Our y-intercept is 2, which is pretty easy. Now, if you want to follow our instructions above about how to find the y-intercept, in order to find the y-intercept, we set our x equal to 0. And if we do that, 3 times 0 plus 2, 3 times 0 is 0, plus 2 is 2. And that's how we wind up with a y-intercept of 2. Now, if you know anything about y-intercept form, which is what this equation is in, y equals mx plus b, your b is your slope, your m here is your slope. So I think I said that twice. So your m here is your 3, that's your slope, and your y-intercept is your b, which is 2. All right. The x-intercept, maybe not so straightforward, but we still follow the same process, right, as we did to find our y-intercept algebraically. Now to find our x-intercept, what we have to now do is set our y equal to 0. So if I set my y equal to 0, I've got 3x plus 2 I need to solve for my x now. So to do that, I'll subtract 2 on both sides. And I get negative 2 equals 3x. I divide by 3. And I get that x equals negative 2 over 3. So my x-intercept now is negative 2/3. Now, a lot of times they want you to write your x and y-intercepts as coordinate points. And if we're going to do that, our y-intercept has a 0 as an x, and our y-intercept here is 2. Our x-intercept, on the other hand, our x is negative 2/3 and our y is 0, so as a coordinate point, it looks like negative 2/3, comma 0. Okay, now if I want to graph this, I'm going to sketch a graph over here to the side. So I've got my xy coordinate here plane. This is my x, this is my y. And let's see. So 2, 3, 4, 5, 6. 6, 1, 2, 4, 5, 6. Alright, so I'm going to change colors when I graph this to a nice green. Alright, so I'm going to start out with graphing the y-intercept, which is 0, 2. And it's the y-intercept because it's where the graph crosses the y-axis. Okay, now you can also graph your x-intercept, which is negative 2/3, 0, which is about right there. Now you have 2 points and you can draw your line. If you're unsatisfied by those 2 points and you want to draw some more, or if you didn't find your x-intercept to begin with, what you can do is employ your slope. Now your slope is 3. And the way we're going to do this is we're going to use a slope of 3 over 1, which is the same thing as 3. The reason I'm writing it 3 over 1 is because I want to rise 3 and I want to run 1. That's why we call it rise over run. So if I start at this y-intercept, I'm going to rise 3, 1, 2, 3, and I'm going to run 1. And I'm going to put me a point right there. And if I want to do another point, I could rise 3 more and run 1 more. Okay? If for some reason in your graph you don't have enough space to rise 3 and run 1, but you have space to go down, what you can as well do is rewrite 3 as negative 3 over negative 1. Because those two negatives are going to cancel out and give you a positive 3 anyway. In this case, what you'll do is you'll go down 3, 1, 2, 3, and you'll go left 1, and you'll plot that point. Now I have several points, so drawing this line should be fairly easy. Try to put it through all of these points here, and this is my graphed line. So we can use our slope and a point to graph the line. We can use our 2 intercepts to graph the line. We've got all kinds of options to graph as well. And it's always a good idea, since you have access to technology, to use your TI-84 calculator to check your graph and make sure it looks approximately correct. Next, we're going to move on. We're going to talk more about this slope-intercept form. So the slope of the graph of the equation y equals mx plus b is m, just like I stated above. This m that sits in front of your x is the slope. That's very important. The y-intercept of the graph is b. So the graph crosses the y-axis at 0b, just like we discussed in the previous graph. So this b here is your y-intercept. Okay. So question number 1 here says find the slope and y-intercept of the following examples. The slope is just the number in front of your x, which is 7, and your y-intercept here is just your b. Now there is supposed to be a positive b here, so if there's a negative out in front of that b, you need to include it on your y-intercept. Okay, so our y-intercept here isn't just 12, it's actually negative 12 because of that negative out front. Okay, now here we have one that's laid out slightly different. What I have here is 2x minus 3y equals 12. Now, don't go assuming that your slope here is 2, because it is not. You have to get your y by itself, and you have to get it in the slope-intercept form here before we can start picking out our slope and our y-intercept. So what we're going to do is we're going to solve for y and get y by itself, and then once we do that, we will be able to pick out our slope and our y-intercept. So I'm going to take this 2x minus 3y equals 12. And I'm going to solve for y. First thing I'm going to do is subtract 2x from both sides. And that's going to give me negative 3y equals negative 2x plus 12. And then I'm going to divide by negative 3. Okay. Now negative 2 divided by negative 3, if I want to simplify that, it's going to give me positive 2/3 because the two negatives are going to cancel out and I still have my x. Now I also have to divide 12 by this negative 3. 12 divided by negative 3 is negative 4. So simplified, I should get y equals 2/3 x minus 4. The key here, if you didn't catch it, the key here is that you have to distribute this denominator to both terms because it has to go to everything in the problem because we divided by it here, and we also have to make sure it goes to both of these terms. I see a lot of instances where people forget to distribute that negative 3 to that constant term out here on the right. So be sure to do that. Now once we have it laid out like this, it gets pretty simple. Our slope now we know is 2/3 because we saw for the y it's by itself. And our y-intercept is negative 4. But you have to get that y by itself before you can pick out the slope in the y-intercept. Now we need to know the definition of the constant rate of change of the linear function. Y equals mx plus b is m. Honestly, constant rate of change is the same thing as the slope of the graph. It's just a fancier name for it that you sometimes see in word problems. So if you see something asking for the constant rate of change, honestly, it's just asking for that m, which is just the slope of your problem. Don't let it confuse you. So if you see this example below, it says using data and projections from 1990 to 2050, the percent of Hispanics in the U.S. population can be modeled by h of x equals 0.224x plus 9.01 with x equal to the number of years after 1990. Now it's going to ask us, it says, what is the constant rate of change of this function? It's just asking for the slope, guys. Remember, the slope is the number that's in front of the x here, which is 0.224. So constant rate of change here, 0.224. Very, very simple. Don't let it trip you up. All right, moving on. Try and move on. But let me scroll down. Now, obviously in this class, we want to try to tie some of this stuff back to some real world examples. So what we like to do a lot is, or what I like to do a lot when I teach it is try to tie it back to a profit, revenue, cost situation. Okay, we're doing some basic math here, but we need to tie this basic math back to some real world concepts. So just a refresher for you, if you don't know anything about profit, revenue, or cost, our profit is equal to our revenue minus our cost. Now, like, okay, Mr. Shipes, what is revenue? Well, revenue is price per unit times the number of units. Okay, so you're going to make off of whatever you sell, and every time you sell something more, you're going to make more, right? So if you are selling trucks, and each truck is $40,000, and you have 20 trucks, you could make at most $40,000 times those 20 trucks, right? That's your revenue. That's the money you're bringing in. But on top of that, when you run a business, you have cost. You have variable cost, and you have fixed cost, and that makes up your overall cost. Okay, so we have our three parts here. We've got our profit, revenue, and our cost. Revenue and cost make up your profit. Now, when we break it down, we have what are variable costs, which are costs such as like a light bill, a water bill, or any input cost that is subject to change from pay period to pay period. Not all costs are the same month to month, week to week, even day to day sometimes. Those are your variable costs. But there are costs that are fixed costs that don't really change that much. So fixed costs are things that don't change much, typically stuff like rent or any input cost that doesn't change. Okay. I hope your employer or whoever you're renting the building from, if you're having to rent a building for your work, isn't changing the rent every month. Hopefully it's at least set for a 12-month period or something like that, hopefully longer. So that would be a fixed cost. Now, we're going to get into marginal cost, revenue cost, and marginal profit, but don't get too tripped up on those. Those are just fancy words for the slope of each of the respective functions. So marginal cost is just the slope of the cost function. Marginal revenue is just the slope of the revenue function. And marginal profit is just the slope of the profit function. It's that simple, guys. So if we look at this example here, it says a company produces and sells a smartphone with revenue given by R of X equals 89.50x dollars and a cost given by C of X equals 54.36x plus $6,790, where X is the number of smartphones produced and sold. We want to know what is the marginal revenue for this smartphone. Okay, well, marginal revenue, that's just the slope of the revenue function. the slope of my revenue function is just 89.50. So that's it. It's that simple. Now, B asks us to find the profit function. Now, we have to remember that profit, P of x, equals revenue, which is R of x, minus our cost, which is C of x, right? We got the money we make. Now we got to take out our expenses, which are our cost, and then whatever's left over is what we get to profit from our business. So let's do this function combination real quick. Our R of x is 89.50x. And we're going to subtract our cost. I'm going to put our cost equation in parentheses because we want to make sure we distribute this negative to all aspects of our cost function. So we got 54.36x plus 6,790. Now we need to do some simplification here. So like I said, it's very important that this negative here gets distributed to both this 54.36x and it also gets distributed to this 6,790. So before we go truly simplifying, essentially what our equation is going to look like here is 89.50x minus 54.36x minus 6,790. Now we can simplify this a little bit by subtracting that 89.50x from that 54.36x. And if we do that, we get 35.14x. And then we also have to bring down this constant, which is that minus 6,790. And now we have our profit function. So our profit function here is P of x equals 35.14x minus 6,790. So now we can answer C, which is what is the marginal profit for this smartphone? The marginal profit for the smartphone is just the slope of the profit function, which is 35.14. And we're done with C. That easy, guys. All right, now we have a few special linear functions we really need to look into. The first one being the constant function. The constant function takes the form y equals b, and it comes from y equals 0x plus b. So when our slope here is 0, it kind of gets rid of that x and we're just left with that constant, right? Some examples of this are y equals 3, y equals 5, y equals 10,587, and even y equals 0.0593. Any constant, basically, where we don't have an x, all we have is y equals a number. The next important function we need to know exists is the identity function. Now, the identity function is simply where y equals x, and it comes from the situation where we have y equals 1x plus 0. So essentially, our y-intercept is 0, and our slope is 1. Okay, that's the important part about the identity function, is simply the slope is 1, y equals x. Now, in this follow-up example here, number 1, it says, which of the following functions are linear? A says y equals 3x squared plus 2. This one is not linear. And the reason this one's not linear is because our x has an exponent on it. In order for it to be linear, our x cannot have an exponent on it. It needs to be in the form y equals mx plus b, not mx squared plus b, right? So is this linear? This is not linear. A is not linear. Now, B, I have 3x plus 2y equals 12. Now, it's not in slope-intercept form, which can be kind of tricky. So if we wanted to, we could put it in slope-intercept form or try to put it in slope-intercept form and see if it's linear. Let's try to do that really quick. So if I subtract this 3x over so that I can get my 2y by itself, I'm going to get 2y equals negative 3x plus 12. And then to get that y by itself completely, I'm going to divide by 2 on each of these terms. And I'm going to get y equals negative 3 over 2x. And 12 divided by 2 is 6, plus 6. Now it's in the form y equals mx plus b, which is a linear form. So yeah, this one is linear. This is definitely a linear function. If I look at C, I get y equals 1 over x plus 2. Now the problem that I have here is this x is in the denominator. And in order to be linear, the x can't be in the denominator. It has to be in the numerator. And there's no way for me to get this x from the denominator back to the numerator. Therefore, this is not linear. Now, number 2 is going to ask us to find the slope of the line through these 2 points, 4, 6, and 28, negative 6. Now, I'm going to let this one be x1, this one be y1, and this one be x2, and this one be y2. It doesn't matter if you switch the order there and let this one be x2, y2, and this one x1, y1. It'll work out either way. But let's work it this way. We're going to go y2 minus y1 over x2 minus x1. Now we got a situation where we got negative 6 minus 6. Negative 6 minus 6 is negative 12. I know some of you probably thought that was going to be a 0 there, but it's not. Remember, negative and negative, you add and keep the sign. And we've got 28 minus 4, which was going to give us a 24. We've got to reduce this fraction, and it reduces to negative 1/2. So our slope here is negative 1/2. Very nice. Now, number 3 asks us to find the slope of the line in the graph below. Now, what I like to do is I like to find places where it hits a point pretty definitely. Okay, so you don't want to, sometimes you get a graph where it doesn't exactly hit at a spot. You want to know that this graph definitely hits at a point. I can definitely tell you, looking at this graph, that it hits right here and it hits right here. Okay, so it hits at a good point here. So it's hitting to me right here at negative 2, 0, and right here at 0, 4. Now what I'm going to do in order to find the slope is I'm going to start here, and I'm going to count up to here. So I'm going to do rise over run. So to get from here up to here, I have to rise to 4. So my rise here is a 4. Now I got to figure out how many I've got to run. I've got to run 1, 2 to get here. And then I can simplify and say 4 divided by 2 is just 2. So my slope here is equal to 2. Now what we have to be careful of on some of these graphs, especially this one, is you have to notice that vertically we're going up by 2, but horizontally we're only counting by 1s. Don't let that trip you up. You got to check your scale here and go by your scale. So even though it looks like we went up 2 and over 2, we actually went up 4 because we're counting by 2s on the way up. And we're only counting by 1 on the way over. So be really, really careful of that. 4 follows up and it says if a line is horizontal, then its slope is blank. Now, a horizontal line. Now, if you want to think about it, on a horizontal line, how much do we rise to get to our next point? On a horizontal line, we rise 0 to get to our next point, and then we run a ways to get to our next point. So we rise 0 and we could run 1, 2, 3, 4, whatever, but the 0 is on top here. So let's say we run 4. That would be a horizontal line. Rise 0, run 4 to get to my next point. In which case, your slope really just winds up being 0. So what you need to remember here is that a horizontal line has slope 0, and a vertical line is when your slope is undefined. Because in a vertical line, you are going to rise however many you're going to rise. Because it's vertical, you can go up as much as you want to, down as much as you want to. So you can rise 4, but you're not going to get to run left and right because it's a vertical line. So you're going to wind up with something like 4 over 0, 5 over 0, 1 over 0, whatever it may be. And when you have that 0 in the denominator, that's what makes it be undefined. All right. 5 gives us an equation here. I'm going to switch colors of my marker real quick back to blue. So 5 gives us an equation here, 3x plus 2y equals 7, and it asks us for the slope in the y-intercept. So in order to do this, I'm going to put it in Y-Intercept form, slope-intercept form. So 3x plus 2y equals 7. First thing I'm going to do is subtract 3x from both sides. So I'm going to go 2y equals negative 3x plus 7. And then I'm going to get rid of this 2 here. So I'm going to divide by it on both of them. So y here equals negative 3 over 2 x plus 7 over 2. Let me get rid of this little tick mark here. All right, so if I'm looking at it, our slope is negative 3/2, And our y-intercept is 7 over 2. Now remember, sometimes they ask for your y-intercept in your point notation here, in which case it'll be 0, 7 over 2. If it asks for just the number, just give it the number. If it asks it and it wants it in your point form here, give it in your point form. Now 6, it gives us another equation. It says 5y equals 2. So 5y equals 2. I've lost my pointer here. So what I still need to do here is solve for my y. So I need to take this 5y equals 2 and solve for my y. So I'm going to divide by 5 on both sides. And I need to get rid of this tick mark here and this one. And I see that y equals 2/5. Now, I don't have an x in this, which means if it was in technical slope-intercept form here, that it would look something like y equals 0x plus 2/5, right? So technically my slope here, if I don't have an x, means there was a 0 out in front of the x, so the slope is 0. And my y-intercept here is 2/5. Now, like I said, if you want to write it as a point, you can do that. It'd be 0, 2/5. All right, 7, and I'll change the color for it too. 7, we have x equals 6. So x equals 6. We need a slope and a y-intercept for this. Well, this one can stump you, but don't let it stump you. When in doubt, draw you a coordinate plane, like I'm doing here, and we're at x equals 6. So 1, 2, 3, 4, 5, 6. And what I'm going to do is I'm going to graph this. So at x equals 6, 1, 2, 3, 4, 5, 6, I've got a point here. Now, the only thing that this can equal is x equals 6. But if I come up here, and I've got all these points here, x equals 6 is at 6, 0. But x also equals 6 at 6, 1. And x also equals 6 at 6, 4. And x also equals 6 at negative 3, 6. Or 6, negative 3. Right? So x equals 6 at all of these points on this vertical line. And that's the key. X equals 6 is a vertical line. So this is the equation, x equals 6. And if it's a vertical line, our slope is undefined. And if it's a vertical line, it doesn't have a y-intercept. So it has no y-intercept. So you can say no y-intercept, you can say none, any of that's fine. Okay? And it's that simple for number 7. Now number 8, y equals 50,000 minus 100x from 0 to 500. We want to find the slope and y-intercept. We want to determine whether the graph is rising or falling, and we want to graph the function on the window that is given. So let's start out with the slope and the y-intercept. The slope, my m here, is 50,000, or is it? Now this is an important point here, because a lot of what I see each year in my class is that whatever comes first, some of my students like to let that be m. That's not the case, guys. The case here is the m is whatever is in front of the x. So my m here isn't 50,000. My m here is negative 100. My y-intercept is the 50,000. So if I were to write this in slope-intercept form, it would be a little more appropriate to do negative 100x plus 50,000. Okay? So my y-intercept here, my b, is 50,000. Don't let it trip you up, because it'll try to trip you up by putting your y-intercept before your slope. But remember, your slope can always be found because it's the number in front of your x. Now we've got to determine whether this graph is rising or falling. And we can do that directly from the slope. A positive slope means that we're rising. A negative slope means that we're falling. So because we have a negative slope here, we are falling. Now we have to go to the TI really quick, and we have to graph the function. So I will see you over on the TI graphing calculator. Grab yours. All right, so hopefully you have your TI calculator ready to go. I'm going to go to y equals. I'm going to clear out my old y equals here, and I'm going to type in 50,000, which is our equation, minus 100x. Okay, we want to graph it on that window they gave it to us. So the window they gave to us was 0, 500. So my x min is 0, my x max here is going to be 500. Now in order to get this to look right, what I'm going to do next is go to zoom, and I'm going to go to zoom fit, which is 0. I'll scroll down to 0 so you can see it. You can really just hit the 0 and it will zoom fit for you. If I do zoom fit here, I do notice a little extra stuff here, and I see those little points. Those aren't part of my graph. What you'll notice if you go to second stat plot, remember last section when we had our stat plot turned on? I'm going to turn it back off just so it won't interfere with my graph. And now all those little extrapolous points are gone, and I can see my graph very clearly as a downward sloping line. It's that simple to do with your graph. Remember, if you turn your stat plot off, you might have to turn it back on later when you come to a stat question. But right now we have it off. We have our window on that 0 to 500. We did a zoom fit to get the y into range where we can get a very nice picture of our graph. And we are ready to go. We see a downward sloping function on our graph. That easy. Alright, on to number 9. If a linear function has points 2, 1, and 6, 3 on its graph, what is the rate of change of the function? Well, rate of change is just the slope of the function. So that's all we have to find. If I let this be x1, this be y1, this be x2, and this be y2, I can easily find the slope of the function, which is the same thing as the rate of change. I'll just go y2 minus y1 over x2 minus x1. 3 minus 1 is 2, 6 minus 2 is 4, and I wind up with a rate of change of 1/2. That easy. Now 10 is going to follow up and ask you a little bit of a trivia question here. Make you think about what is an identity function. It says, what is the slope of an identity function? We have to remember that our identity function is y equals x. And the slope there is just that 1 out in front of the x, right? So the slope of the identity function here is just 1. That right there means you have to rely on knowing what the identity function is. So it is important to know what your definitions mean and stand for. Now, number 11 says the balance of the federal direct student loans S of T in billions of dollars for selected years from 2011 and projected to 2023 can be modeled by S of equals 130.7 T plus 699.7 with T equal to the number of years after 2011 and S equal to the balance in billions of dollars. What is the slope of the graph of this function? So you got a really complicated looking question there, but when it comes right down to it, it's asking you a really simple answer. The slope of the function is just the number in front of our variable here, which is simply 130.7. That's all. That's all it's asking for. Now, number 12 says the percent P of high school seniors who ever use marijuana can be related to X, the number of years after 2000, by the equation 25P plus 21X equals 1,215. It asks us to find the x-intercept of the graph of this function. Now, in order to find the x-intercept of the graph of this function, what we need to do is let our P equal 0. So if we let our P equal 0, we've got 25 times 0 plus 21x equals 1,215. Well, that 25 times 0 just cancels out. We're left with 21x equals 1,215. If I divide by 21, then my x here is just equal to, let's find the decimal. You can type it in your calculator like I'm doing over here on the side, and we get 57, I'm around 2 decimal places, so 57.86. So, the x-intercept of this function is x equals 57.86. And if you wanted to write that as a point, it would be 57.86, comma 0. Okay. B says find and interpret the P-intercept of the graph of this function. So I'm going to change colors so it doesn't interfere. And we're going to find the P-intercept. In order to find the P-intercept, we're going to set our x equal to 0. So I get 25P plus 21 times 0 equals 1,215. Now that 21 times 0 just cancels out. I'm left with 25p equals 1,215. So 1,215 divided by 25 gives me 48.6. So all I did here on this next step was divide by 25. And I get a p that is equal to 48.6. So p equals 48.6. If it wants you to write it as a point here, you'll get 0, 48.6. Now, what it wants you to do here is interpret the p-intercept of the graph of the function. So you have to know what your p is. P is the percent of high school seniors who ever used marijuana, right? So, and X is the number of years after 2000. So, we have to know what year 0 is here. And the key here is this alignment of number of years after 2000. So technically, our 0 year is 2000. Now, in 2000, 48.6% of high school seniors had ever used marijuana. That is how we would interpret this. So we would interpret this as 48.6% of all high school seniors in 2000 had used marijuana, 2000 being our year 0. Now we can graph this function on our calculator very easily. So I'll see you over there really quick. We'll graph it on our calculator, have a good look at what this function looks like, and then we will call it a lecture day. But before we get moved over to the calculator, we need to do just a little bit of work here, because I can't type this function in as 25p plus 21x equals 1,215. Now I am going to let y be our p here or p be our y here, but I have to solve for p before I can type it in my calculator, which means I need to start with this 25p plus 21x equals 1,215. I'm going to scroll down to hopefully give myself a little extra room to work on it. And I'm going to solve for p. So I'm going to subtract 21x to start with. And I get 25p equals negative 21x plus 1,215. And then I'm going to divide by 25. So I need to divide everything by 25. And I'm going to get p equals negative 21 over 25x. And then, let's see, plus, and we determined that this 1,215 divided by 25 was 48.6. So I'm just going to write 48.6 here. Now 21 divided by 25, if you wanted to write that as a decimal and have your whole thing as a decimal here, you could say negative decimal 84x plus 48.6 if you want to convert everything to a decimal to make it easy to type it on your calculator. So let's jump over to our calculator real quick, get this graphed, and see exactly what this function looks like. Alright, so we're over here at our calculator. I'm going to go to y equals. I'm going to clear out that last function we had in here. And I'm going to type negative 0.84x plus 48.6. Now, be sure when you hit that negative in front of that 0.84 that you actually use the negative button and not the minus button. Otherwise, you're going to get an error for your input. So make sure if you're doing a negative number, you actually use the negative and not the minus. If you're subtracting something, use the minus, but if it's just a negative number out front by itself like this is, make sure you use the negative button. Now, I've got this typed in. We want to graph it. I'm going to start, I always like to start my graphs if I don't know what the axis looks like. I like to start my graphs on a standard zoom. So I go to zoom 6, which is your zoom standard. Now, a lot of times when that happens, it doesn't show up, like there's nothing showing up here. So what I'll do in that case is I'll go to a zoom fit, which is zoom 0. And when I zoom to fit this, what I notice here is that I have a decreasing function. Okay, and what that means is that the function is going down. Initially here at 2000, which is our 0 point here, so our x equals 0 point here, remember that was that 48.6. And as our years continue onward, our marijuana use decreases. Okay, so that's the way our function lays out. So we see our function here as a decreasing function. We've graphed it on our TI-84 calculator. If you want to, you can go second table and look at some of your table points. Like I said, at year 0, you should have that 48.6 like we found in our mathematical work we did on our notes. And then you can see as we continue on in years, that percentage goes down, steadily down. So we have completed lecture 1.3. Please go online and do your chapter 1.3 homework that's associated with this lecture. If you have any questions, any problems at all with the lecture or the homework, please be sure to send me an email and let me know so I can reach out and help you with your work. Other than that, I will look forward to seeing you back here for chapter 1.4.